All right. Hello, and welcome to my Tom Talk. So I did want to talk a little bit on this video about why pathfinding wasn't the answer to what the problem I was trying to solve. I got suggestions from, I believe, Soil, from that other guy, and a couple other people, people that I think about a lot, that they all suggested, well, why don't you use breadth first search, or what is it, Jerska's algorithm, or I think somebody else brought up, there's another famous one with a number in it, I can't remember it. Anyway, it wasn't about pathfinding. The problem I was facing was not about pathfinding. So here is the map as a whole, and I'm gonna hide something that, wait, that's not hiding it, there we go. So I want you to look at the road. So pathfinding is about finding paths. And then, I mean, it's exactly what it is. It says, okay, if I start over here where my mouse is, over at the top left-hand side of the map, and then I'm gonna get down to the right-hand side of the map, what's the quickest way I could do it? And this was my first thought that I mentioned in the video a long time ago. It was like, okay, well, what I could do is I could just define all of these intersections in the middle, and then define all of these endpoints, and then say, okay, well, pick two random ones. Pick maybe this one over here on the top right-hand side, and maybe this one in the middle on the left-hand side, and then find a path to, from point A to point B. That sounded, I mean, there's no reason that would not work. It absolutely would work. But then Ribo had the brilliant idea of like, well, instead of pathfinding, why not just have it like, because the car does not need to go from point A to point B. If I'm just picking 2 points at random, then I obviously don't care where the car is going. So Ribo's suggestion was, well, just have the car make a random selection when it gets to an intersection, which on the surface sounds a lot easier than doing pathfinding. And it was. I mean, it was easier because you just get to these turning points, and I'll explain more about that in a second. And then you just kind of randomly pick, okay, do I turn or not? It's a lot easier. My problem wasn't about paths. The problem was, if I zoom in a little bit, the problem was knowing where the cars need to be drawn, because I didn't want. Let me see. Can I highlight? Let me make sure I can highlight. Wait, why can't I highlight? Okay, there, I can highlight in red. All right, if a car is driving on the right-hand side of the road, I need to define, okay, it can turn here because if it comes down and it turns right, it's gonna stay on the right-hand side of the road. It cannot turn at this point, even though this is a single intersection. I did not wanna go through the map and define each little thing, like, okay, if it's coming down this way, then it can turn in this direction on this square right here, or it can turn in this direction because if you're coming down the right, you can take a left at this square, you can take a left because then you'd be on the right-hand side of the road, on the other side of the street. And I didn't want to do that. I wanted to be able to basically say, okay, here's one square, this is the type of intersection I have, give me the points. And that was what I had struggled with a couple of days, for like 3 or 4 days, because it was a matter of, okay, I want you to give me this square. I want to give you the square, and then I need you to calculate. Okay, at this square you can go this way. At this square you can go this way, but then also on this square you can go that way, or on this square you can go straight. I wanted it to be able to calculate all of that on its own. I didn't want to have to tell it where it could go, what directions it could go at every single square in an intersection. And the reason that is because if you look really closely here, you can see this single intersection has 4 distinct points in which a car can make a decision or turn. And then when you multiply that by all the intersections on the map, that's a lot of freaking work that I'm not willing to do for you people for free. So I wasn't going to do that. And besides, it was more fun coming up with an algorithm that did this automatically. So what I ended up coming up with was something like this. So here I define an origin point, which I call it an origin point, which is by definition the top left-hand square of every intersection. So here is an intersection, and so the origin point would be right here, where my mouse is at 93, 130, what you can see over in the left-hand side of the window there. And there are several different types of intersections. So you look at this one, this is a T intersection. But if you think about the letter T, let me bring it up. Or no, I'm not going to bring it up. You can visualize it. Think about the letter T, and then you rotate it, and then you rotate it again. And actually, I will bring it up because you people are stupid, and I feel like the only person that would get this probably is Ribo, and maybe that other guy, and then maybe Tobacco. I actually meant to say Tobacco instead of Ribo, but maybe some of you would get it. But anyway, I like clear explanations. So think about a T, right? Here's a regular T, and I called that a T0, a T0 intersection. This is when the car is coming from the bottom, going up, and it has to make our left or right-hand turn. And then if you rotate that 90 degrees, which I'm going to draw bigger, I don't know how to, where did my little mouse go? Or my brush go? There we go. This would be a T90 because we rotated the T 90 degrees, and then you have a T 180, and then you have a T 270. And these are the types of different T intersections. And then likewise, you have L zeros, and then you have, what would we be? This was always kind of a mind fuck. An L90, and then this is a L270, and then that's the third one there is an L180, and then this is an L270, and then you get back. So these are the type of T intersections you have on the map. These are the L intersections you have on the map. And the L intersections, and there were all these little distinctions you had to make because it was like, the L intersections, if I zoom in, like these, he comes up and you can only go right because you're driving on the right-hand side of the road. You come down, you can only go left because you're driving on the left-hand side of the road. But in an L intersection, there's no choice to make. If you're driving this way, you have to turn right. If you're driving this way, you have to turn left. That's in contrast to a T intersection, whereas if you're driving this way, when you get here, and I discussed this in one of my other videos, when you get here, you can either turn right or you can go straight to this square. And then when you get to this square, you have to go to the left. So in that sense, when you come here, this is this right here, I'm going to highlight this in red. This right here is what I called a decision point. And these were all generated automatically because in this case right here, I defined the origin to be this point, and then you have another point here, and then you have these two lower points that I've already drawn. And then the algorithm is smart enough to know that, okay, well, the point here on the bottom left-hand side is a decision point where he can either go down or he can go right. And I know that's a little confusing, and this was something I had to wrap myself around too, because I didn't want to define the direction in which the car could turn from the car's perspective. I needed to know the direction the car could go from the screen's perspective, which was like kept confusing me because I kept thinking, okay, well, the car's driving this way and then you're going to turn right. But no, you're not turning right, you're actually turning down. Whereas when you come to this square over here, you're turning up. So it was a bit of a mind twister there. That had to deal with that. But the nice thing is really I only had to figure it out once, and of course I worked on the T0 case. You only had to figure it out once because once you figure out here, like, okay, this is a decision point where he can go this way. This is a non-decision point where he has to go this way. This is a decision point where he can go this way. You figure these things out, but then once you figure them out, you're like, okay, well, then it's easy enough to just rotate it, and then you can rotate it again, and rotate it again, and rotate it again. But I also went kind of crazy with this because the T intersections really are kind of like L intersections. And also the interesting thing about that is like if you add two L intersections together, how did it work? I don't remember exactly how it worked, but there was something, there was some nice composition going on where if you added two L intersections together, there was something where two non-decision points equaled a decision point, but only if there was some other condition. And so this was where like the math degree inside of me started to really come out because I started to abstract all of these different operations and these different group operators and just really think about this and like, how could I composite this? And how could I make it so that, like, you know, okay, all I have to really define is just a T intersection. And then I went crazy with it because I was trying to really abstract it out. Like my first goal, I set out to just define a T0 and then say, okay, computer, rotate the T0 for me. And that ended up proving a little more difficult than I had liked. And so I had to step back for a minute and say, okay, well, instead of struggling with this, just don't be fucking lazy and just manually define all 4 of the T intersections. All you got to do is just define them. And then, like I said, when I'm actually writing the code, once I define the first one, the other 3 just kind of flow together because it's like, okay, well, then I can see I just have to, you know, instead of adding 1 to the x-axis, I'm adding 1 to the y-axis and things like that. It really just kind of came together nicely. So here's a configuration file. Here's like my first rough draft at defining most of the intersections on this map. There are a few little challenges. Like this is an intersection that won't quite work with the data structure I have. And at this point, I'm kind of lazy and I'm thinking I'm probably just going to change this intersection and then make this road, where did it go? Make this road all double lane all the way across to the end of the map. I think that's probably the thing to do there. And then down here, I had put 2 one-way roads because I believe if you look on a map of Tucson, these roads actually are a highway. And they actually kind of curved down, but I didn't care about that. So I see a way that I may be able to support one-way roads, but again, I think I'm just going to end up changing all these to a double lane road like this one, just because I'm lazy. And also, even if I am able to support double one-way roads, this intersection here just kind of looks like, I don't know. I guess, wait a minute. Single cross. Yeah, no, see, I have no way to actually, and I did this to myself, I have no way to fine-grainedly define the points, but there's no reason I couldn't add that. There's no reason I couldn't just add another field here where it says intersection. I couldn't just add something else, like intersection points or whatever. And then that way, instead of defining an intersection that defines 4 points for me, I just define those points myself, which actually is very plausible. One problem with that, though, I do know that I have a limitation in the decision making where is that? Where is it? Yeah, right here. So yeah, I do have a problem in the decision making such that any one point only supports 2 directions. I don't know that that would be a problem. So if you're here, you're driving up, you can't turn this way, you can't turn this way, you can turn that way, you can go straight, or turn left, or you can go straight or turn left. Okay, so that might not be a big deal if I just add a way to be able to define the points manually. Okay, that's actually something to look into. That actually might be worth doing. So, all right. So, but I think you get the idea. As I said, it was not about pathfinding. It was about laziness and not wanting to define. Like here's a good example. I had to again. I just wanted to define this one point here at 4473 and say, okay, this is a cross intersection that has a double vertical lane and a double horizontal lane, and then have it figure out all the points for me. And it was pure laziness. But again, you know, it's easy to say, okay, well, all right, well then, all you gotta do is just add 1 to the X and add 1 to the Y or where appropriate. But then you have to know, okay, well, when can you turn right? When can you turn left? When can you turn right or go straight? Exactly, you gotta. So it all came together in the end. It just took a while to get there. Here you define your intersections. But the actual representation in the code itself is It's a very simple structure. It's actually just 3 variables. It's the point. So as I said, each individual point where you can turn, where to go. It is the turn you can make. So here, that would be right, because you're coming up, and you can't come from the right-hand side of the screen to go left. Actually, you can't come from the right-hand side of the screen at all, because that means you would be driving on the left-hand side of the road, so that's wrong. So you have a point, which in this, our example would be 4675. You would have a direction, or a turn, which is right, and a decision point, which says, okay, when you get here, I can make a decision to take my turn or just keep going. So actually going back to the other intersection, it shouldn't be a problem to support that. Okay, good. We're all set. Let me show you in the game what I've done. Now the cars aren't driving on it yet, but I have written some code. Okay, so here already the game has drawn a path. It's generated a Ribo path, and this is what the whole video is about. I wanted it to show you, and this is a very long Ribo path too. So right now I only have these 2 origin points. I've only defined, the origin points are defined a little bit differently. They're defined up here as edges, and I've only defined 2 of them. So this Ribo path starts here, and then Tommy's going to walk this Ribo path. I had to add color coding to the Ribo paths because it was hard to tell where they began, where they ended, where they turned. So let's follow this Ribo path. So we come down, and then this Ribo path, he takes a left. Looks good. He's on the correct side of the road. He takes a right. Still on the correct side of the road. He took a right still. He takes another right. Still on the correct side of the road. Takes another right. All right. And he's taking a right again. He's coming all the way over here. Where is he going? He's taking another right. I don't know why he's only taking rights. Why is anybody taking lefts? It kind of has me a little suspicious. Has he taken a left yet? Here's another right. Here's another right. Going up. Okay, he does take a left. So he takes a left. In that Ribo path, there was literally only 1 left. Okay, so, but you can also generate a new one just by pressing the space bar. So let's see. And here's another phenomenon. And okay, if I look here, this is a perfectly valid Ribo path. It comes on, takes a right, takes another right, and then leaves the screen. And that's it. That's the end of the Ribo path. The Ribo paths begin off screen and they end off screen. So here's one. Here's another one. Come down, take a right, go all the way to the right, keeps going, keeps going. Is he going to turn? No, he's going to turn. Takes another right. Why aren't we taking any? Oh. So what this probably is, if I had to guess, this is me getting a point wrong in my definition. So if I look here, I can see that this is 93.43 is about where Tommy is standing, 93.42, but the path should actually probably be more like 93.39. So if I look 93.41, I bet this should be 39. That's probably why that is drawn like that. So let's try one more, and then I won't bore you with any more Ribo paths, but it is kind of funny to watch Tom walk around. So here, this Ribo path comes down, goes to the right. Now this looks like an interesting one. He takes a left. Oh, he just makes a U-turn. He's like, nope, I'm getting out of here, and then walks off. All right, one more. One more Ribo path, and then, no, okay, see, just one more. No, not that, not that. Why? Okay, there we go. All right, so let's see, we go down here. Now, where is he going? Now, that's hard to see. I am not sure where he went. The color coding actually probably needs to be better color coded, but he comes up and makes a U-turn at some point. Comes down, looks like he makes another U-turn, eventually comes down, makes a left, makes a right, makes a left. Okay, so I am happy to see that it's making that the algorithm is making left-hand turns, because that one path for a minute there looked like it wasn't making left-hand turns. So anyway, the Ribo paths they're looking pretty good. I think I just need to add a couple of those things that I talked about, just support for defining an actual point instead of having to define an intersection, and then I should be able to start adding the cars. Here's an interesting little thing. Oh, wow, look at this. Okay, so the path comes down, it took a left, took another left, took another left, and took another left and then proceeded down. So this is, I wonder why my loop protection's not working. This is something that's interesting. This should not have been allowed by the loop protection. I bet I know why. I know why that was allowed. I need to fix my loop protection. So, and then it comes down, comes up to the right, comes up, and takes a left. So those are the Ribo paths. And you know, I thought that was a cool little thing to look at. You know, just seeing them visually on the screen like that and being able to draw them randomly. And these are all, like I said, randomly generated paths, which is what makes them pretty cool, and why, you know, like I said, why pathfinding was not the answer. It wasn't about trying to find paths. It was just about, or not trying to find a path between point A and point B. It was just about trying to find a path. And that's what I've done. So thank you for watching. I appreciate it. And I'll do another video whenever I get the cars moving around the screen. Bye.